Okay, so let's continue with sketching this graph. So y equals 1 over x minus 3 plus 1. So what are a couple of things we should know right off the bat by looking at this equation? We should know our asymptotes right off the bat. They are, a non-permissible value is going to be x equals 3. So I know that x equals 3. I'm going to have an asymptote. I'm going to slide this down here. Is going to be right here. Okay, what else do I know about another value that's impossible to have? Okay, so I want to write that as an equation. So my horizontal asymptote is going to be y equals 1. You can't just say 3 and 1. Okay, that's not going to be good enough. You have to state them as equations. All right, so two things really quick. As soon as we glance at our equation, we know this already. All right. Now, we can tell our graph used to be, our 1 over x parent graph used to look like this, right? And we know that it has gone right 3 and up 1, and that's exactly what our asymptotes did as well. Okay, we can see that by our graph. Now let's kind of figure out some finer details. We need to have a couple of nice points on our graph. So how do we figure out our x-intercept? Okay, set y equals 0. And how do we figure out our x-intercept? Set x to 0. Okay. Now our vertical asymptote is going to be x equals 3. Make sure we state that as an equation. And okay, so when we set x equal to 0, when we set x equal to 0 and y equal to 0, 0 equals 1 over x minus 3 plus 1, minus 1 equals, and let's solve. What do we end up getting? So we get negative x plus 3 equals 1. If I multiply both sides by x minus 3, so I get x is equal to 2. So my x-intercept is 2. And then when I set x equal to 0, I have y equals 1 over minus 3 plus 1. So what is that value there? Y equals negative 1 over 3 plus 3 over 3. So y is 2 over 3. All right. So let's plot these points so we have a couple of nice points on our graph. So my x-intercept is when y is 0. So x is equal to 2. My y-intercept is when x is equal to 0, so 2/3. So that's right around here. Okay. And now the point that was, I need a point over here in this quadrant, right? Where was the point originally, if we kind of think of our parent function? Where was this point and this point? This one was at 1, 1. And so where has it moved? It's moved up 1 and right 3. So where will it end up? So it was here, goes up 1 and right 3. So it actually ends up right here. So that's how I know where this point is. So this is at 4 and 2. Okay. So, and then I could just draw in the shape for that. Okay, as long as you have a couple of nice points, you're good to go. All right. Okay, so what's our domain and range for these guys? So our domain refers to the x values that are permissible. So x is an element of the reals except for x can never be 3, and my range is y is an element of the reals except for y can never be 1. Okay, so it's basically going to be your asymptotes that you're stating. All right, so there are 3 more examples that I'd like you guys to do. I'm going to hit pause here, and I'm going to give you guys time to do them, and then we'll cover them together. Okay? Sound good? Okay. Okay, so let's, all right. Is it working now? All right, okay. Let's go over this question. So the first thing I did was I remembered the fact that the base graph, I remembered the base graph of -1/x, okay, is going to look like this. So I have in the back of my head that the curves are going to be in the 2nd and the 4th quadrant, all right? Now I'm looking at my equation, and I've got a -2. So the 2 means that there's a stretch, okay? And now if I look at the base graph from the original 1/x, there's a reflection over the x-axis, which makes it look like this. And my asymptotes and my entire graph moves right 1 and up 3. So then I figure out my x-intercepts. So I plug y = 0, and I get 5/3 for my x, which is approximately 1.6. And then I figure out my y-intercept, which I use my x = 0, and I plug that in, and then I get y = 5. Okay, so then what I did was I graphed my asymptotes first, and then I graphed my x-intercept and my y-intercept. So there's my y-intercept, and there's my x-intercept there. And then the next thing I did was I filled in all of the stuff in my chart. Okay? So my non-permissible value and my vertical asymptote here, my x-intercept, y-intercept, my horizontal asymptote, and my domain and range. Those kind of things are all intertwined with each other. I wanted another point on my graph just because I wanted one. So what I did was I looked at my equation, and I chose an x value. I chose x = 3 because when I plug in 3 minus 1, I end up with 2, and then 2/2 reduces nicely to a whole number. So that gave me a nice point. So that's the only reason why I have this point here. Okay? On the provincial, you're required 2 minimum points. So I just threw that in there just to make myself feel better. All right. Now, the last part here says explain the behavior of the graph near the non-permissible value and the end behavior of the graph. So near x = 1, so that's a non-permissible value. As x approaches 1, the absolute value of y gets really large. Okay? It explodes. It gets really big. So that's going up and big. The end behavior as the absolute value of x becomes very large. So this is x = 1. As it approaches it, the y values get really big in the positive, and from this side, as it approaches it, it gets really large in the negative. So that's why we just say the absolute value of y gets really large. Okay, and the same thing happens for the other one here. So we've got y equals 3. The absolute value of x gets really large as it approaches it. So over here, that's the positive, and over here, this is the negative. All right? So that's what that's talking about. Any questions?